for all of you. Hello, everyone. My name is Fernando Moro. I'm assistant professor in the Department of Civil Construction and Environmental Engineering. If you have any questions on the presentation, some of the researchers of this project are online. I will be glad to answer the questions as well. So write them on the chat and I will go over them. The title of the presentation is Requirements of Using Aerial Vehicles in Field Experiments to Find Displacement. Very multidisciplinary research topic. The authors are Royan Assimi, Nicolas Cobo, Joshua Diaz-Rosa, James Woodell, Dr. Sujan Piyushgar, who is actually online from California, phoning in. He was working on this on his master's, and we're glad that he's with us, and myself. So again, this is a project where the expectations, the results have exceeded the expectations, and I'm very glad to be sharing that with you today. Actually, I think I need to duplicate here to be sure people can see it. Okay. Sorry, there is a... Okay. So let me move on. This is the contents of the presentation. If there is any problem with the presentation, please let me know. The motivation is the monitoring of infrastructure in transportation infrastructure. The background of our research was specifically on railroad bridges. With approximately 100,000 railroad bridges in the United States, the priority is to maintain and repair management approach of this problem. So we're going to talk about maintenance of existing infrastructure, the state of the art, as some of the former presenters show us. You could see the inspection can inform the prioritization of maintenance, repairs, and replacements. As you can see, this is conducted by humans. So what we are looking at here is applying technology to monitor these critical bridges or nodes of our infrastructure. And we are interested in using sensors. We've been using sensors in the past. We build wireless sensors and attach them on the infrastructure, but they are costly. They take time and access. You need to actually climb to that structure to attach your sensor. So we are trying to explore other approaches, which is with the use of drones. And the goal of this presentation is to actually explore how can we enhance the drones to collect information by adding some devices to these drones. So the traditional monitoring with the UAVs is using cameras, where you can collect videos or images of that infrastructure, and you can inform of the condition of that bridge. We are interested in using computer vision for obtaining this information, but we are thinking, could we actually collect data on real time using the drone that tells you the condition of the structure on real time? Can we actually sense the status of the bridge? We've been using this enhanced drone for structures. We have interest on large drones in our application because we're gonna attach hardware and software that drones don't come with. So we're actually interested in building our own types of drones. So it's related to this stakeholder-based sensing. So we ask the stakeholders, what do they want to collect? And we create the drone to collect that information. One of the areas that we work, actually this was work with the Los Alamos National Lab, was to create this hammer that the inspector uses for collecting this tapping without climbing. So we added a hammer to the drone, and in fact, this is a Tran-SET project for a Tran-SET 4 we are going to use for rocks of interest for the NMDOT. But in this was the incubator of that tap testing. And in this case, we created a off-the-shelf wireless tap testing that we designed so it wouldn't have a resonance. And again, the Dr. Mascarenas in Los Alamos and I worked in one summer. Emmanuel Ayorinde, he actually was a community college student in mechanical engineer who did very well and they actually won the summer student competition. And we created crank rocker. It's a very simple mechanism where you can have a eternal tap testing with the same frequency and energy. So that way you can compare the taps that you obtain. This is the drone that we created. And this is a little example of the crank rocker. It's a couple clovises and a 6 volts solenoid that can be tapping with that hammer, and with the sound we conduct a machine learning approach of that sound. In this case we use 5 samples. It's a little loud. Let me lower this down. And this is the indoors validation. So we collected 100 hits and do some machine learning classification. We have 5 regions. We do the training and the testing with half of them, 746, 373, and 373. And the confusion matrix was very good, with an exception of the specimens 2 and 3 that have some areas, as you see on the 3rd row and the 3rd column, we have a 15 miss points there. But keep in mind, this was similar specimens, and we didn't filter the data, we just hit. We even used the first hits and the last hits, which we should have removed because they had less different energy, and that even then we wanted to show what we got, and it was actually very good. Why are we interested in displacements? We've been talking with the railroad industry, and they wanted to measure how much the timber bridge is moving under that train crossing. And you're seeing there a few inches transverse movement. If you can look at the pile, it's moving maybe 1 or 2 inches. They don't know. They just look at it, observe at the train, look at the train crossing, and try to assess if it's 1 or 2 or 3 inches by eyesight. So we were thinking, okay, we installed the sensor. We're going to have to climb there. Actually, we did that. We attached a sensor on the pier, but it would be nice if instead of climbing that 15 feet, you could fly with your little drone without having to climb and wait for the train and know if it's 1 or 2 or 3 inches, instead of having to look with your eyes. My eyes are not that good anymore. So we are looking into integration of a laser. This is the work that Piyush Garg did for his master's in UNM in electrical and computer engineering. It was an excellent dissertation. Attach this vibrometer to the drone and fly and shoot the laser and see how much is moving. So this is the setup, and this is a little video. I know it's a little junky and jumpy, and I won't keep you, but since you didn't come to Albuquerque this year, we hope that you can come in the future, and we can show you the different projects that we have. This is one of them, where you can see the Sandia Mountains. You can hope to see the tramway on the background on those Sandia Mountains on the background. And this is the Albuquerque Balloon Fiesta. Thank you to Dr. Jan. And this is Piyush Garg running his dissertation there on real time. This is the laser and the bore, and this is the displacement monitoring validated with the LVDT. And as you can see, the drone has a tether, and also the laser was actually, this was great, excellent results, but we have some limitations. So we have some limitations I want to share with you. The laser was excellent accuracy, but it was too heavy, and you could say also expensive. By talking with DOTs, they are interested in more, they're thinking, well, if the drone crash, then I lose $100,000, right? So no, they don't want that. They want something that is low cost. And also they're interested in combining the drone with other technology to obtain the pseudostatic, the non-dynamic low dynamics or low frequency responses on those vibrations. And they also want to measure in real bridges. We heard that from them. They don't like the tether. They want to fly the drone high and far and not depend on a tether. So for the field implementation, what we've been working is closely with this is the TRV project idea, with our panel review on the last year and a half, and this is what you see, a strong involvement with the railroad TTCI. Thank you to Martira Mullin, Sandro Scola with CN, doing order from TTCI in Pueblo, Colorado, and we have Dr. Fierro from the UNM, and David Mascarenas with Los Alamos. Very good panel review. And this is one of our visits last year to the TTCI, where we have some kind of exposure to the group, and we could see the bridge. We were planning on doing this before COVID, so you can see these nice deck girders, how we could fly our drone. And this is Roya Nassimi, Jens Woodall, Roya's topic is the bridge. Now we have Maimuna, Shin, Rafa, Dilendra, Sang. It was it's about 4 hours from Albuquerque. And this is what we are thinking when we can go. We're going to have the LVDT, and we're going to have the drone about 20. Actually, we're going to get closer than that, but it's going to be in a controlled environment. Safety is their concern. These are some of the initial plans that we have with Dr. Ali and Biden Liu when he was here for that field implementation. And this is the instrumentation that we're going to do for the field validation on TTCI. So this is kind of the plan, and this is what we've been doing in Albuquerque to prepare for that. This is Roya is there supervising the flight. As you can see, we're writing the papers for this. It's actually a very successful topic. We like drones, and we like to attach different enhancements. You can see a close look on the laser that the team put together. You can see the computer vision working there. We have been very successful in terms of the field implementation, and we are publishing these results. This is another video. I know it on Zoom may not work so well. This is Roya, this is Nicholas, the pilot. Doctors to be very soon with his electrical and computer degree. And this is the flight, again, untethered, completely wireless, all developed by the students. They did everything that you see on the air. All designed by them, all validated by them, programmed by them, and it's untethered, as you can see. So I will stop here with the conclusions. We are very interested in enhancing drones for the DOTs. We know the NNDOT is interested on drones. We know other DOTs are interested in drones. We want to sense the structures besides the computer vision. We're interested in computer vision. We're interested in any machine learning, artificial intelligence approaches on that data acquisition. We're interested in mechatronics, robotics, and signal processing. So we're going to enhance the sensing of the owner of their bridges. Whichever they want to measure, we like to build it for them. So we want to ask the owner what they want to collect, and we will attain it safely. One of the outcomes of this approach is that the students become their own CEOs of their ideas. They submit their patents with the University of New Mexico, and they can get credit for the inventions that they do. And they prepare something that is the reality of 2030, which is going to be civil engineers in charge of teaming up with other fields, mechanical, electrical, computer engineering, and work together, programming interfaces, owning these inventions. So it's very fascinating to be a witness to that. We'll be waiting for the testing on the real train crossing event. To conclude, I have a picture that I think we have someone to take for us, obviously. This is not all of us, but most of us. Piyush is not here, or Joshua, but we have Dr. Zhang. He's an associate research professor in UNM and strong supporter of our work. Jens Woodall, yours truly, Nicholas Cobo, and Roya Nassimi. This is becoming her thesis, and she's Should be happy to answer any question. We all hope that you can come to Albuquerque soon. We will take care of you when you come here. And thank you for your attention. Let me see if I can answer any question. Okay. So I have a question about the accuracy of the method and about who paid the patent application. If I can answer that, or Roya can answer that if she desires to do so.
Hello, yes, I can answer that. About the accuracy of the method, this is basically developed for finding the displacement in a non-contact way. It's working like we had the root mean square within millimeter range, 5 to 6 millimeter. We had the peak error about like in centimeter range, but that was like the centimeter difference happened when we don't have displacement actually. So we're pretty well around millimeter accuracy when we're trying to obtain a pseudostatic and dynamic displacement. And for the patent, I think these kind of official things, Dr. Murrow is working on them. You can ask.
Thank you for passing the hot potato to me. We are very privileged in UNM. We had the UNM Rainforest. It's an initiative from at the university level. They are very unique for innovation. So they encourage the researchers to submit their patents, and they support us. I cannot give you all the details. I can provide that to you if you're interested and choose to know more details, but in fact, they are extremely supportive of the students' ideas to be protected early. So they are the ones who allow us to do this. Other questions? Any other questions for any other of the presenters? Not just me, but maybe Rafa Cardona, Marlon Agüero, or Dr. Oscan. If there are no other questions, I'm very glad to conclude the session 2A. If you have if you want to you had the opportunity, please join us for let me minimize this. You can join us for session 3 at 1:30, and it's a different Zoom link. So be sure to choose the other Zoom link. If you don't have it, feel free to email me, and I will send it to you. Rather than that, have a great lunch. Thank you for the presenters for their excellent presentations and for a great turnout to this session. Enjoy the rest of the conference. Thank you. Dr. Hassan, can you hear me or you are busy? I wonder if I should stop recording here. Or Crystal, how are you? Oh, Crystal left. Hi. Hi, Piyush, how are you?
I'm good, Professor. How are you?
Good. I have to tell you, it went